He's an author, researcher, with multiple radiant energy concepts, generator in particular, which will be demonstrated here for you today. This clean, safe, virtually limitless energy source may hold important applications in all of our futures. With that, I'll let him elucidate these concepts for you. Please welcome Mr. Bruce Perreault.
1996, my research was publicly announced. The focus of this research many people have come to know as radiant energy. I can still recall the excitement that was caused by this announcement. Today, 3 key sources of energy will be presented. They hold the greatest promise in retrospect to all other sources of energy that I have researched. I now draw your attention to the first of these 3 unique forms of energy. What you see here is called a star chamber. It operates on the principle as our sun. Transparency, please. This photograph demonstrates the tremendous volume of tritium gas that is a byproduct of our solar furnace. We've all been told that the sun is a hydrogen burner, but what you're not aware of is that the hydrogen burn is triple weight hydrogen and not the normal weight hydrogen that we're familiar with here on Earth, that we breathe, the impurities in our atmosphere. The moon, having no atmosphere, acts as a perfect sponge to this gas. Remembering that tritium decays to helium-3. You can imagine the billions upon billions of reserves just waiting to be mined on the moon. The figures shown here give you an idea of the enormous amount of this fuel that has accumulated over the millenniums. The sun is nothing more than a huge hydrogen burner, deuterium-tritium burner to be more exact. I will begin by showing you a short 3-minute clip put together by NASA that depicts helium-3 as a future resource. Please run the first video.
It was a time of wonder and discovery.
Roger, Eagle, bend dock.
6 trips to the lunar surface revealed much about our closest celestial neighbor and changed forever the way we view our own planet. Today, NASA is looking towards returning to the moon. A permanent lunar base would complement space station Freedom and provide a springboard for manned missions to Mars. And if researchers at NASA's Center for the Commercial Development of Space in Wisconsin are successful, the first lunar settlers will also be miners. Actually, this large automated vehicle would do most of the work, processing the moon's rocks and soil to remove a potentially valuable product, helium-3. Just 25 metric tons of this rare isotope, roughly the capacity of the shuttle cargo bay, could provide enough energy to generate all the electricity used in this country in an entire year. Helium-3 is produced by fusion reactions in the sun and carried through space by the solar wind. Earth's atmosphere shields us from the solar wind, but it has been depositing helium-3 on the moon for more than 1 billion years.
We're right
Former
where we
Senator
wanted to
Jack
be,
Schmidt was part of the Apollo 17 mission, which marked our last, or as he likes to say, our most recent journey to the lunar surface.
Colors anyway.
We can't always use fossil fuels for the production of electricity. There are many environmental reasons why you don't want to do that. One of the most popular now, of course, is the addition of CO2 to the atmosphere. We don't need to panic, but we ought to be making those kinds of research and development plans that we have an alternative to coal and other fossil fuels in the not too distant future.
Studies indicate that the amount of radioactivity in a device like this generating energy from helium-3 will be 1/1,000,000th less than in nuclear systems used today. And no greenhouse gases, acid rain, or solid wastes will result. The proposed mining system will be equally kind to the lunar environment. Once helium-3 has been boiled off, the untainted rocks and soil return to the surface, leaving it essentially unblemished. The process should also produce a number of byproducts, including water, which will be of great value to a lunar colony. And according to Jerry Kolsinski, a professor at the University of Wisconsin and member of the NASA Commercial Development Team, current oil prices make helium-3 an even more attractive alternative.
At today's prices, helium-3 would be worth $4 billion a ton, which would make a shuttle load worth about $100 billion. And that's enough, I think, for any businessman to figure out a way to make a profit.
Helium-3 mining, using the moon's resources to meet future energy requirements on Earth.
Okay, cut that video. This type of chamber contains 2 electrodes that are coated with a special coating that was a spin-off from us trying to figure out what the formula was for the Swedish stone material that Morey was using in his device. And one night my associate was fooling around with the material and he dipped 2 pairs of electrodes in there. I don't know why he did it, but then when fired up with the high-frequency power source, a star was formed in the middle of the electrodes. And when he sent me a picture of this, I immediately recognized this effect, and I saw this effect on a video that I had purchased from Richard Hull from the Tesla Coil Builders Association in Richmond, Virginia, and I immediately recognized it as the star mode effect that the fuser patent was fuser device was of Farnsworth for his fusion apparatus was generating. What makes this effect unique is that we were producing it in air, and the fuser has a bugle effect, which is electron leakage, and the device was never able to break even for this reason. Now, putting these electrodes in a deuterium gas or helium-3, we can get a clean burn. If we use helium-3, very minute amounts of radiation is produced, and we have a very efficient fuel source. And as you saw, there's a lot of helium-3 stored up on the moon, and this could be used as a reactor. And I demonstrated this effect at the International Tesla conference in April of last year, and surprisingly, about 6 months later, it was announced by Daimler Chrysler their what's called their fusion star. If you could please put on the transparency. And I had been running a research and validation program, had people sign non-disclosures, and I was sending out these electrodes left and right. And it's apparent that they have analyzed the material and now have applied for a patent. They're getting millions of dollars in military contracts. never called me, never offered me a grant to continue other research, and I've tried to call their lawyers, and all my messages are ignored. But they have a laboratory equipped with millions of dollars for good equipment, in which I don't have all the equipment's come out of my own pocket. But this here, transparency machine again, please. I don't know if that shows up clearly here, but it may on the videotape. This shows their test results. When you put deuterium gas between these electrodes in this chamber, neutrons are emitted, and these neutrons can be shut off, put on and off by a flip of a switch, therefore making a portable source so that you can generate radioisotopes for medical uses and other various uses. Also, a reactor could be designed that's very safe, that you can turn it on and off at a flip of a switch. But this technology has been swiped from us because we're not a big corporation. We don't have the kind of development money that they have at their disposal. But I'm showing this as a matter of public record that we're the first to have discovered this. Could you please show the next video segment? Next video segment will show the video that I spoke of, that I recognized the star mode effect. It'll demonstrate the perfect ion recombination of star mode, and we are achieving that.
Mode of operation. It is called star mode. This indicates superb ion recirculation. You will not see much of star mode above 10 microns of pressure. It's a very delicate mode. You need to be in the sweet spot. If you're producing superb ion recirculation and are in star mode in air, with just a vacuum pump pulling down in air, then you are ready to proceed with neutron production. Therefore, it is highly recommended that you build a concept demonstrator before and achieve star mode before you begin to work for neutrons. Don't go rushing after the neutrons until you have first achieved star mode in air. Because once you achieve this mode, the only thing you need to do is to introduce deuterium gas and get your voltage up and supply enough current.
We're doing this without vacuum with the specially
It
coated
must be
electrodes.
remembered that the past discussions are idealized situations. There are different moderate interpretations for what's going on, but this, for most purposes, is a simple layman's way to understand what's going on inside the fuser. It is nothing weird. There's no bizarre science going on. It's straightforward, normal science. But when you substitute deuterium gas or a deuterium-tritium mix, you're capable of doing fusion. Many of you may ask why star mode is so important and why superb ion recirculation is so important. The key thing to remember is that in the Poisson, the accelerated ions, especially at lower pressures, do not all collide. Instead, some zip right through the Poisson, exit the other side, and then once outside the Poisson, if they do not recombine, they literally turn around and then come back into the Poisson for a second pass, some a third pass, some a fourth. A lot depends on your critical pressure and the voltages used in the chamber. One mustn't think that you have perfect Newtonian orbits of these particles. That is not the case. But when you are in star mode, you're probably getting the best ion recirculation possible. It has been shown by George Miley and his group at the University of Illinois that the star mode is capable of producing, at minimum, twice the amount of neutrons as the common Poisson mode with no star. So this is what you want to shoot for.
Okay, that's good. Transparency machine again, please. What you see here is a pair of blunt hypodermic needles. They're hollow, coated with the material. If I have time today, I'll show it. It was demonstrated in the chamber yesterday at the workshop. If I have time, I will show it. Okay, you can cut the transparency. Now we come to our second source of energy. The main component that generates electrical power may at first glance appear to be nothing more than an atomic battery. It will be seen from the description to follow that its energy generating mechanism is entirely unique, and the advantages over prior art atomic battery technology becomes apparent from the following description. There is a source of energy that could provide us with all of our energy needs for countless of generations. With this energy, we can reach for the stars, or at the very least explore our own solar system. The fuel that I speak of is called polonium. It releases more energy than any single element ever to be discovered by man or woman. Polonium was the first element discovered by Madame Curie in 1898 while seeking the cause of radioactivity of pitchblende. Her electroscope showed it separating with bismuth. Polonium is also called radium F. Polonium is a very rare natural element. Uranium ores contain only about 100 micrograms of this element per ton. It is found in radium and its abundance is only about 0.2%. In 1934, it was found that when natural bismuth-209 was bombarded by neutrons, bismuth-210, the parent of polonium, was created. Milligram amounts of polonium are now prepared this way. By using the high neutron fluxes of nuclear reactors, this is achieved. Polonium-210 is a low-melting, fairly volatile metal, 50% of which is vaporized in air in 45 hours at 131 degrees Fahrenheit. It is an alpha emitter with a half-life of 138.39 days. A milligram emits as many alpha particles as 5 grams of radium. This represents a whopping 5 curies for 1/1000th of a gram, making polonium 5,000 times more powerful than radium. The energy released by its decay is so large, 140 watts per gram, that a capsule containing about half a gram reaches a temperature above 932 degrees Fahrenheit. A few curies of polonium exhibits a blue glow caused by excitation of the surrounding gas. Almost all of its alpha radiation is stopped within the container that it is stored in, where it gives up its energy. For these reasons, polonium is an attractive lightweight source of energy. 25 isotopes of polonium are known, with atomic masses ranging from 194 to 218. Polonium-210 is the most readily available. Isotopes of mass 209 with a half-life of 103 years and mass 208 with a half-life of 2.9 years can be prepared by alpha, proton, or deuteron bombardment of lead or bismuth in a cyclotron. But this method has proved to be quite expensive. My solution is to extract the radon gas that radioactive ores generate. Radon-222 decays to polonium about 3 or 4 days. Better yet, thoron gas, known as radon-220, decays in less than 10 hours to polonium. Polonium is a pure alpha emitter, and my tube design will absorb this type of radiation and convert it to useful electrical energy. Radioactive animations expelled from radium, thorium, or radioactive ores can be concentrated on a negatively charged conductor. Radioactive matter decays and expels animations that travel to a negative electrode. The collecting distance will depend on the potential of the charged wire. This animation is widely known as radon gas. It will decay to polonium in a few days. If thoron, radon-220 gas, is generated, then the decay is almost instant. There she is. Transparency machine. And this is what I'm calling a glow regulator. And we did receive a provisional patent on this year, which is good for about a year. And we have to apply for a non-provisional within a year in order to keep our patent rights on it. This glow regulator was a joint effort between me and a virtual lab partner named Aussie from Australia. Polonium is deposited, keep the transparency up please. Polonium is deposited on a thin wire forming cathode represented by 2 here in this figure. Electrons, electricity, are emitted from this wire. These electrons rush towards the cylinder anode 1, thus generating electrical current. This is very similar to what the Koreans are doing up in Canada. The difference is here that we're using a thin wire, and this thin wire represents a high resistance. And because it's such a high resistance, the wire gets red hot. This is no ordinary atomic battery. The plated polonium heats the cathode wire too, dislodging millions of more electrons than a cold cathode would in a conventional atomic cell. In other words, you can shut off the negative high voltage there, and it'll remain hot from the polonium coating on the wire and continue to emit electrons. And this configuration will give you electrical current. It's a unique generator. The plated polonium heats the cathode wire too, dislodging millions more electrons than a cold cathode would in a conventional atomic cell. One of my unique tube designs will generate the high voltage normally associated with atomic batteries. However, one of its unique characteristics is that it also converts the heat of the polonium to amperage. A little extra amperage goes a long way in increasing the wattage to higher power levels. When positively charged helium atoms, alpha particles, collide with the electron cloud that envelopes another atom, its positive charge is canceled by the collision. You can shut off that transparency if you like. This is atomic absorption. Atoms ring like a bell when this absorption occurs. This ringing generates energy, high wavelength energy, X-rays in the gamma range. The wavelength of this generated X-ray depends on the charge of the alpha particle and what type of atom it hits. If the X-ray generator has an energy level that exceeds 10 million electron volts, it is absorbed by atoms. I don't have that transparency to show you. When they return to their ground state, they are broken loose from the shells of their parent element. Isotopes may be created by gaining or by losing neutrons as a direct result of this process. We can efficiently do this by exposing certain atoms to high-energy alpha particles. From this mode, it is clear that nuclear changes can occur by electronic stimulation. And by the way, this process either overlooked or suppressed by the powers that be who come up with the nuclear theory. And I believe that they came up with this theory for national security reasons during the developing atomic energy to be used as bombs for destructive purposes. Before that, nuclear development was going along at a good rate, and it wasn't clouded. Genuine results were being reported, and people weren't lying about the results.
1947, with the National Security Act, the National Security Council was formed, and research on deuterium was totally classified as classified, top secret.
Yes. And they got all these minds together and came up with a theory so that it would lead people away from how nuclear reactions were actually occurring. In a nuclear reactor today, the reaction, according to my findings, my results with my radioactive ores, fission is not occurring by neutrons. Neutrons are being created as a byproduct of the reaction. What's actually occurring is alpha fission, or true fusion. You get the fusion first and the fission as a secondary reaction. An example is, and this is in all the textbooks, they haven't been able to hide, when an alpha particle of sufficient kinetic energy bombards, say, a light metal like beryllium, an ultrachemical reaction occurs. We're all told that helium is inert chemically. Sure, it's inert to oxygen because helium is an oxidizer. It's an oxidizer when you have enough kinetic energy to affect the reaction. When you have enough kinetic energy for the reaction to occur between helium and alpha particle with, say, a target of beryllium, you get a fusion reaction, whereas when the two combine with this ultra-chemical reaction, you now have a new element, carbon-12, with the release of one neutron. And I don't know if this has been overlooked or what, if it's been suppressed as a result of these theories that came about during the atomic bomb era. But what we're being told is cold fusion today is in reality a catalytic reaction. And I found this out by finding an article in an old electrical experimenter magazine. I often try to obtain magazines that are pioneering forefathers, and in the case of Madame Curie, woman. What were they reading? I try to put myself in their mindset before all this smoke screen was put in front of us. And I find some very interesting things. And the one thing I found was an article of placing a polonium wire with a high purity alcohol, denatured alcohol, in a closed container. And when you put that platinum wire in there, there's some oxygen in there from the air that when you put the platinum wire in, something very interesting occurs. That wire will start to glow, a red heat. And it took a few trial and errors. I almost gave up, but and finally it occurred. For about 15, 20 seconds, I self-sustained a red heat with that platinum wire. And I theorized that if you were to put it into a liquid solution and put, I haven't tried it yet, some of you might want to try it at one point, put some hydrogen peroxide in the solution, put some extra oxygen in, and that's what these cold fusion people are doing. They're using various oxygen releasing compounds in their solutions. They put excess oxygen into the solution. And when you put the wires into the solution and give it a 1.5 volt charge, one electrode draws hydrogen gas, the other oxygen gas. When there's enough hydrogen gas absorbed into the lattice, say polonium, it reacts with the excess oxygen very violently, and you have a tremendous amount of heat and a misconceived phenomena, and which will bring us nowhere as far as producing an economic source of energy. What it's doing is it's lining their pockets with money, and we've got to stop this kind of waste and do some real research and get a reliable energy source in our homes so that we can take our freedom back. Okay, one question. Yes.
I know that polonium is one of the most toxic substances known. It is ingested because it causes cancer at a very, very low concentration.
Yes, I pointed at in some of my booklets on the website. I put it in red print. Yes, it is very toxic, and you don't want to absorb any kind of radioactive gases into your bloodstream. Well, the point I wanted to get to here is that if you use thoron gas, it's very safe because the half-life of thoron gas is about 10 hours, and it poses no contamination problem. It's gone. Whereas if you're using radium, like I'm using my experimentations, it has a very, the lead-210 as an end product, I can't remember off the top of my head. Can you help me here, Paul? What's the half-life of lead-210?
Like 47 days. It's short.
Well, I have it on the chart here, but I thought it was something like 13 years.
It's fairly short.
Okay. We'll put on the transparency, please. I'm kind of jumping ahead because of the question that was put before me. The end decay product of radon gas, what decays to, is lead-210, and the half-life, half of it's gone in 22 years. Whereas if you use a thorium source that generates thoron gas today, and they hide that, it's not called thoron gas today, it's called radon-220, and I had a very difficult time researching thoron gas because it's just not there. It's written as radon-220 now. And the last disintegration rate, daughter product of thorium, or as a result of the thoron gas, is a polonium-212, and that's incorrect. That's one of the last decay. Okay, lead-212 has a half-life of 11 hours, means it's gone. Half of it's gone 11 hours. So after about a day, there's no more contamination. It's just the next decay chain here is polonium-212, which lasts 0.3 microseconds, and you end up with stable lead-206. So, and that does not pose a radioactive hazard for us. Okay, you can shut that off. When positively charged helium atoms, okay, I'm wrong, and I guess I should have had the decay chart up next. Could you put on the transparency again, please? Okay. As you can see from these charts, that if thorium is used as a parent source, then there is minimal danger of contamination. And the old pioneers knew this, and often they would use the thorium because they knew that, especially if they were using intense sources of thorium, radiothorium. Thorium's almost non-radioactive. It's because of the radiothorium in it. Very intense source of radiation to experiment with because it has a very short half-life. But these guys were smart back then, and they knew that if there was they spilt it everywhere, they wouldn't have they could clean up very nicely because in a day the the end product is lead 206. Is that 206 or 208? 208. A lot of these I don't know off the top of my head. The Perreault valve is a unique way to convert the energy of radioactive particles that are a result of radioactive decay to electrical energy. And I've been saying this since I first started lecturing in 1996. And I'd like to point out something that was just recently posted on the internet as being some new breakthrough by the Department of Energy. The energy of an alpha particle will be used as an example. The average alpha particle has a kinetic energy about 6 million electron volts that will ionize inert gas in a valve. Therefore, if an alpha particle dissipates all of its energy ionized in inert gas, about 100,000 electron pairs are generated over a path length of about 4 centimeters, 1.5 inches. As a result, a charge of 10 to the minus 14th power coulombs can be collected by the electric field inside this valve. I guess before I show you this next transparency, I'd like to read a few excerpts from this announcement on the internet right before I did this conference. Maybe I can put this on the transparency real quick. Transparency, please. You can see the source of the information is a Science News Report and page on the internet, Science Daily. Study looks to nuclear energy as micro-scale fuel. Nuclear engineering professors James Blanchard and Douglas Henderson, along with electrical engineering professor Admit Lal, are leading the 3-year, $450,000 project. The United States Department of Energy, which looks at potential new uses for nuclear energy, supports the research. The idea is to harness the natural decay of radioactive material and convert it into power. Does that sound familiar? As a power source, without use of a reaction such as fission or fusion. Now, mind you, in my radiant energy cells, which is a marriage between a primary cell chemical reaction and the high voltage byproduct of an atomic battery, I have a way to take low-grade ore and make it give out intense, big wallop, as T.H. Morey would call it, so that we can economically produce radiant energy cells. The Department of Energy, as far as I know, doesn't know how to do this, so this may be my ace in the hole. By keeping the material securely contained within the device, he said, the majority would decay before it leaves the product, so they're admitting that it's safe. But if I do it, it's not safe. We would capture the energy from that decay and convert it into a power source that could run a sensor or a tiny moving part, Blanchard said. The project is part of a nuclear engineering education research at the Energy Department, which primarily funds university-based projects in fission and other applications of radiation. This is part of a small category of funding. Small category? $450,000? I wonder how long they're going to milk this one. That encourages potential alternative uses for nuclear energy. And I'm reading this as a matter of public record. So that, they're calling it something else, some fancy made-up name, so that when you hear about it on Good Morning America, you'll know that I publicly announced this pioneering research back in 1996. Okay, transparency, please. This is the Perreault valve, what I call the Perreault valve. You can call it anything else, whatever you want to call it. But transparency machine, please. And a lot of this stuff has been published on my web. But apparently, when I published this stuff on my web, and you can confirm this with Tom Valone, he's a patent examiner, and I wasn't aware of this. I thought when I was placing this stuff on my website that I was protecting myself as a matter of public record. But apparently, according to the rules of the Patent Office, this internet thing is new, and I guess you can change electronic media. You know, before you could put it on paper, and you know, you automatically have a copyright, and after it's been out there for a year, it's public domain, and some big corporation can't come along and grab a patent. But apparently, when I did this on the with the fusion star mode, it wasn't protected. I don't know why. You know, it was a public disclosure, but it, according to Tom Valone, it's not a fixed. It's not fixed media. It could be changed, so therefore it does not constitute a publication. You're saying no, but you know, ask Tom Valone. He's right there. He's a patent examiner. I don't. Is Tom Valone in this audience today?
They don't know what date it happened, so.
Well, you know, that could be checked with my server when it got uploaded.
Except that could be, I think that could be changed, so it's not like a magazine publication or something? Cast in concrete.
Well, I would think it's a magazine publication. Everybody sees it and they print it up on their printers and so on and so forth. But I opened myself wide up because I thought that it was a public disclosure. But now these big companies can grab the information and get a patent on something that I've released on the internet. Another loophole. Okay. Negatively charged ions are attracted to the positively charged anode in this diagram and arrive a few microseconds after an ionizing event, while positively charged ions are attracted to the negative cathode cylinder lining. A few milliseconds later, these positive ions recombine with the negative ions. The result is an intense short duration of electromagnetic energy. This energy now impinges upon the cylinder's photoemissive material, resulting in a flow of electric current in one direction. This flow of current acts as a valve to many wavelengths of atomic energy. It prevents ions from returning to their originating source. This valve does not change high frequency to direct current. It creates an electrical draft that polarizes the atomic ions. What these guys don't know is that I've been doing these conferences, and this videotape is an automatic copyright. They probably think that this information was recently released on the website, so that may give me some ground there. Just having some thoughts as I was reading this. Last but not least is my jewel, radiant energy. It will efficiently light lights, charge batteries, run motors, and electrical appliances. Over the years, I've been working with radioactive materials, but in the past 3 months, it's come to light that the radioactive materials in the Moray radiant energy receiver was just to ionize the gases as like a cold cathode valve. And you know, just in the past couple weeks, I've been experimenting with this concept to take the ions in the air that originate from our sun, that expel these, what Maury referred to as cosmic particles, were these fast-moving tritium particles hit the atmosphere and create an ionosphere. The clouds, the water vapor forms clouds. The clouds move. Inductively, a charge is induced into them from the ionosphere. These charges build up and then you know, break down the dielectric of our atmosphere and ground out, and you have a tremendous surge of energy there. And that's the energy that T.H. Moray was tapping into. But he wasn't tapping into the electromagnetic release of energy. And that's what our radios do today, very inefficiently. And we need an amplifier to amplify the signals of radio towers because we're tapping into the electromagnetic side of that RF. Whereas if we were to build a radio receiver to tap into the electrostatic side of that RF, we would draw power with very little loss, especially if you're talking about billions of volts represented by that lightning discharge that surges into the ground. It represents almost zero resistance and zero loss once you pick it up at the receiver. The lightning strike just so happens to be most intense in the AM broadcast range at 500 kilohertz, called storm frequency. And a very interesting demonstration, and I posed this question to a lot of you yesterday in the workshop, but I won't give you this brain teaser today because I told you that I ended up telling you that was in the AM broadcast range after I described the demonstration that Maury gave. Maury would transparency, please. This is the same type of crystal radio that Maury had back in the 1920s. I got this off auction from eBay, and luckily I was able to get in time to show you at this conference. And what caught my eye is at the top here, this item is shown in the Sea of Energy 5th edition, but on the back side as his pocket radio. And on the other side is a crystal holder. That's what he was using. Very unique circuitry in here too. The way the coils are wound, they're wound so that they don't have any self-induction. 10 minutes. He took out the Erler crystal and replaced it with the sweetest stone and got wonderful radio reception. And then he replaced that crystal with a specially treated moire lead, they called it. And he was able to power a loudspeaker of the time, which if you went to the workshop yesterday, you saw that it's what I call super unity speaker. Because when I went to measure its resistance, you get all kinds of noise out of it with very, very minimal amperage going through that digital meter. But the next stage of this is to cascade them into you get more power, and that's why Maury had a tuning problem. And I'm running out of time here, so I can't go into much detail. But if you get the workshop tape, you'll get all the details everybody got, and it ended up being about 4 hours. So I've only got a few minutes left, and I'd like to show the antenna hook up here and show the energy. And I held back yesterday. I got a result in my lab before I left. A tremendous surge of energy burnt out the valve, and I had to rebuild it before I come to the conference. I'd like to try to duplicate that, and I don't care if it burns out in 15 seconds. At least you'll get to see the surge of power. So I'm going to kind of have to jump ahead here. And at the end here, whoever hasn't signed up for the raffle can, I'm giving away Atomizer 2000, which will increase your gas mileage. Many different booklets. A drinking bird, perpetual motion type thing of the early 70s. A spark plug that was developed by Hubbard, and I believe he used this spark plug in his device to produce his energy. The spark plug was coated with polonium, and it's not radioactive today. It's decayed out, and there's nothing but residue of lead left on there. But that will be raffled off, and somebody will get it for free. It's a nice collector's item. Could I have my assistant, please, to hold it? I actually need 2 assistants. I need one more assistant so that we can hold up the antenna here. Oh, everybody's jumping up to get electrified.
This one has to stretch out as the antenna.
Yeah, we want to get it as far away.
Yeah.
Try to hold it up. I'm going to try not to cause a fire like I did yesterday.
That's why all the fire alarms are
Okay,
going off.
yeah, we've got to get that untangled completely.
Yeah.
Might have to bring that through a couple times, I don't know. Be careful. Okay, there we go. Try to hold this up. And hold it to, you get, well, be careful.
You have to get back enough to get it, Tom.
Yeah,
Get it, Tom.
try not to hit any metal, I don't want any fires. Hold on, not too tight,
That's good.
because we don't want to dislocate it. I'm a little bit nervous. I'm hoping I can replicate it here and without causing any big disaster. You notice a lot of people standing up on the wall, against the wall. That's what I asked. We do have a fire extinguisher available. I was told we do, but I'm, you know. Okay, let's cross off.
Wires away from the metal table.
There. Yeah, I know. That's what
Need
happened
some
yesterday.
boxes and stuff to set them up.
Let's see what happens here. We're running out of time. Okay. I'm going to try to pull it as far as I can so that I got an inch and a half by half inch surge of energy. Yeah, I know this isn't exactly ideal lab conditions here. Hold on, don't move there. Hold on, don't move. I wish I had time to explain this. There is a battery on here for the electronic pump. In the diagram, I show a passive circuit that antenna ground, but then you add the pump to draw in the energy. Are we out here? What happened? Where? It's on fire? Hold on. That's gonna help. I don't have a ground. It may blow. I've tried to redesign the components to take more energy. So we got leakage. I got too much leakage here, but in the workshop, it's straight white light, and I burnt out the. we're drawing in ions from the air here. And I suspect that some of it's, when it's coming off, it's recirculating through. So in other words, when we convert the high voltage down to a transformer through efficient star mode, in the case of Moray, he used a radioactive material in his tubes to do this efficiently. We light up the bank of light bulbs, and the energy coming off the light bulb, some of it's going back into the antenna. So it's causing what a draft that Moray was referring to, the draft. When you draw more power out, it creates more of a draft. Yeah, so you can see the nodes. Back here. Those are PVC tubes coated with plasti dip. What I can do later is I want to take this apart to show you that there's just a flyback transformer in there. You know, that there's not a bank of capacitors. And there's a lot of leakage on this table here. This is not ideal conditions. But we take this with high voltage, low amperage energy, and we step it down to efficient valve. Those components may be breaking. I've got all kinds of glow here and all kinds of.
Yeah, you can see it.
Making some kind of a. It's making some kind of a tone I've never heard before.
That's your battery shorting out to the high voltage.
What's melting?
It's melding together here. You better shut down.
Okay, I think we're out of time anyway. But I have diagrams to show what's going on here. It's, you know, in the, a lot of you bought the research manual that explains what's going on here. In the manual, the pump's not connected to the diagram. It's shown as a passive device. But adding the pump, well, it's just like an air conditioner that it takes heat particles out of the air. Even if the air is cool, there's still hot particles in the air. This device pumps the ions out of the earth and the ground, negative ions in the ground, and positive ions in the air. And Moray said, it's not the electrons, it's the ions. And these ions are plentiful there's a lightning strike around the earth everywhere. So what we're tapping into is that 2 million watts of energy dumped from a lightning surge into the earth and going through the earth. No different than what Tesla was doing with his magnifying transmitter and transmitting pulse DC to the earth to a receiver, except for now we're going to take this device and tune it in to the resonant frequency, which is peak at 500 kilohertz. We're going to harness the electrostatic field, which there's almost zero resistance to the earth. If we tried to harness the electromagnetic end, that's what radios are doing, and we wouldn't be able to pull power from it. Thank you for coming. We're out of time.
Would it help to cut that antenna to a quarter wavelength at 500 kilohertz?
Yes. I've only been working on this for a little short time without radiation. All this time I've been focusing on the radiation. But the thing is, in space, there's no ambient. So the spin-off that I've been working in, and other people have thought the Moray device was drawing on radioactivity, it's still a viable thing for space, which I'll still develop. We go to the moon, we've got a nice plentiful source of helium-3, which reacted in this